right, so we're doing energy development, more specifically energy development versus ecological sensitivity. And we're definitely still working on our hypothesis. We kept it like super broad for right now, and we're gonna be sharpening it up later. But as of right now, it's wind turbines act as population sinks for certain animal life in regions of California they inhibit. That's where we're currently at right now. Next slide. You wanna go over data set?
Yep, of course. So the data set that we discovered while sifting through a number of sources was a source from the National Renewable Energy Laboratory. And this study was taken from 1998 to 2001, so this isn't a modern data set perchance, but we're still in the midst of looking for something a little more modern or something that spreads a wide span of years. But this data set is a quantitative research that shows the death of bats and other avian species due to wind turbines during this time frame. And this is in Altamont Pass, which is about an hour east of the Bay Area. So in this particular location, there's about 5,000 wind turbines present at the site location, and this just shows a giant list of all of the avian species that were killed, as well as their numbers during this specified time.
And then we were thinking about also layering this with what environmentally sensitive areas that are around this wind farm as well. Next slide.
Cool.
And then this is basically the rough graph that we made from that data set, just focusing on fatalities, because there was also collisions was another one. And then I organized it with like who gets hit the most to who gets hit the least, or who dies least. So our top one was red-tailed hawk, and we thought that might maybe sharpen up our research, and maybe we could just focus on red-tailed hawks. Or other species on that list that might be more of a protected species. It's looking like predator birds are the primary target.
Mm-hmm. Cool.
And that's it.
Great. All right. Thanks, you guys. Any questions for these guys or any suggestions?
The hypothesis, was it inhabit or inhibit?
Inhabit.
Yes, good. So check the spelling. That's good. Good. Awesome. Other suggestions or feedback?
Cool. The only one I would add on this real quick, and this is a great starter, you guys. Good job. Thanks for doing that. It's always hard to be the first group, but you guys did really well. Thank you. I would say this would help to give us some context. Something about the units here. So was this killed per day? Was this killed per year? Was this killed over the 4 years of the study? Give us some little sense of what that is. That would be helpful. But that's good. I like that. Okay, cool. Did you want to?
No, that's great.
Okay, group number next. Equity impacts. Tell me when you guys are ready.
Okay.
Ready, steady, go for it.
Okay, so our hypothesis is basically that policies in California regarding and encouraging the movement away from internal combustion engine vehicles to electric vehicles disproportionately impact disadvantaged communities, most notably in Black and Hispanic communities. Diminished access to electric vehicle charging stations within these disadvantaged communities compounds pre-existing inequities of environmental racism and justice issues, stoking a growing difference in the air quality levels of affluent communities comparatively to the disadvantaged ones. So basically we just want to talk about how, especially in California, there's just so many laws that are, or like acts that are being passed, and like it's encouraging people to like use more electric vehicles, but what if some people just can't afford them. So it's like we're gonna talk about like how that classism is gonna be showing more just by how bad the air quality is.
Next, okay.
Alright, so we struggled a little bit with finding a data set. We could only find sort of like uptick in health concerns related to air quality, and we found like several papers that we kind of like bookmarked to use later. So we just ended up using table data from one of the papers we found that explores like the amount of registered new and used electric vehicles in non-DAC, which is disadvantaged community, and then disadvantaged community areas, pulled from like DMV data. So we have it like classified under like in general like plug-in electric vehicles, then specifics battery electric vehicles, and then hybrid electric vehicles for new and used. used, and you can see that, there are way more electric vehicles purchased and owned, in non-disadvantaged communities. And then, also explored in the paper, but we couldn't find a table that we thought was good enough to reflect it, that because of that, there are fewer charging stations. Most disadvantaged communities are full of people who are renting apartments or homes, and so there are no like outlets for charging your vehicles, so they rely on publicly accessed ones, and there are way fewer publicly accessed charging stations in disadvantaged communities, disproportionately. So that would add to what we found the implications were is that like reduced access to charging stations coupled with unaffordability of electric vehicles means disadvantaged communities do not reap the benefits of those improved air quality goals, and that highlights that inequity issue that we were talking about. Number next.
This is just a graph that we like made really fast with that table we had. So we just wanted to show the difference between like the new plug-in electric vehicles, like the pink is the percentage of non-disadvantaged, and then the blue is the percent of the disadvantaged community, like the ones that have it. So it's just, you can see there's like a vast like difference in the number of cells.
Yeah, and so then the PEV is a sort of a summary of these other ones. So the new and used PEVs are the combination of the battery and the plug-in hybrids. So you can see that disadvantage is significantly lower than non-disadvantaged communities. That's kind of where we started. We're hoping to maybe add in like public transportation type aspect to it as well, but that's all we have so far.
Cool. All right. Thanks, guys. Questions? Questions for these guys or comments?
So would you classify, I assume it's classified as a disadvantaged community by income rates?
Yeah, so we kept seeing the term disadvantaged community across like the different papers that we were looking at, and it seems like it's defined based on like income and then also air quality. It seems like it was the combination of the two.
So so people have used different ones over different time. The most standard now that everybody is using is Cal EnviroScreen. We're currently on version 4 of Cal EnviroScreen. The first version sucked, and it was it was created for Southern California, but then extrapolated to the rest of the state. So it just wasn't really good. It was an example of a tool that someone created for a very specific use, and people weren't stupid or bad. They were applying it in one context, but then people thought, oh, let's apply it everywhere. And that's what led to the poor quality at first. But as I mentioned, we're on the 4th iteration, and people are currently working on the 5th iteration. But what you guys have available right now, publicly available, is the 4th iteration. And it's gotten much better and much more useful. And so that includes measures of income and some assumptions about demographics. And likely exposure to pollutants, in particular airborne pollutants. So people that are nearby, let's say, a transportation corridor that are more likely to be, because of their jobs or their demographics, more likely to be exposed, spending more time in and around those areas. And so I don't know what year you got the study from, but pretty much going forward now, that's what just about everybody uses in California. We have a similar tool from the EPA, which I'm sure will be gutted in the next few months if it hasn't already been. But certainly the California tool is very robust, and for our state is a good default one to look at. That speaks in terms of percentiles. So are you in the most problematic percentile or the least problematic percentile? And that's usually how we classify those. So that's probably the best. If you guys can look at the Cal EnviroScreen, that's probably be your best. And that's usually organized by zip code or census a block. Cool. All right. Sorry, did you want to say anything about that?
That figure was made with the table that you found. Did you look in the paper? Did they give you access? So that table, which is really great, that's like a great starter point too. Those are usually summary statistics of a larger data set. So you want to try to find that larger data set.
I tried and it wasn't linked, so
Yeah.
couldn't find like a data set that wasn't like health impacts from air quality.
Yeah. So hopefully, sometimes we can try to suggest ways of getting access to some of that data, or that's a useful way. You know, we talked about that, like Rosetta Stone, finding that Rosetta Stone. Sometimes just knowing those summary statistics or the tables can give you what a lot of the key variables that they're using in those types of data, and then you might be able to help like your search parameters and things like
Yeah,
that.
the language. A lot of times people, once you figure out that they're using like DAC or whatever, if you go search for that specific terminology, that can lead you to the data sets. Because a lot of times that's the standard units that the experts that work on that particular subject use, that might not be obvious to us, but usually when we put it in the tabular form, they use the sort of like tightest way to refer to that variable. And so that's usually a good way to hunt stuff down.
Cool.
All right, cool. All right, Sea Level Rise Group, or Sea Level Rise Group 1, I guess I should say. All right, you guys ready?
Yeah.
Ready, set, go.
Okay, so we had sea level rise. It kind of took us a minute to get a hypothesis because it was very broad. But for what we have is, if sea level continues to rise and the cost of maintaining and protecting coastal infrastructure in California will increase significantly.
So this is kind of like this is a data set that we found that kind of highlights like the zone area. And the zone area kind of reflects like, so the red zone, yellow zone, and green zone. Red meaning bad, like that means that those are highly impacted areas. And then the green zones are the ones that aren't as impacted. And it kind of just, like, we're looking at the impacts on homes and the percentage of homes impacted by that.
Cool.
And this is kind of just showing the visually where on the coast that it's being more impacted.
And this was from the study we used to research this, like, to get our hypothesis. This, this isn't our, like, our graphs, but it's just a representation of, like, the information that we had found.
Cool. Okay. All right. Good. Feedback, questions for these guys? Thoughts? So one thing I'll say. So some of us, and I think like Sea Level Rise is probably one of the like sort of maybe classic examples of this. Dylan was asking me some questions earlier. Again, we're not. We don't assume that you guys have taken GIS. You are more than welcome to do a map-based visualization. That's okay, but nobody's required to do that. But in some cases, your data might be being communicated through a GIS or a geospatial framework. In which case, you can actually extract the data from these tables, right? And essentially, we're sort of pulling some of that data out and sort of leaving some of that the map aspect of stuff, the sort of the two-dimensional stuff, and that's fine. And so you could, for example, spit this out just based on zip code, and then you could add some of your other things, a household or whatever, average price of the house or whatever the thing that you want to compare it to would be. And so we can help you if you guys are not used to sort of extracting that data. But essentially what you'd be doing is just be pulling out one of the attribute tables from that GIS. Again, you don't have to do that, but for a lot of these things that are very spatially explicit, some of you guys keep saying, all I keep finding is map data. There's tons of data in there. We just need to sort of suck it out to get it in more tabular, usable form for you guys.
Is there like a file converter type thing that you can put that into and extract it, or is there like a link on the website?
No. So you'd want to open it in something like ArcGIS Online or or the computer that you have right in front of you. Log in with that computer in front of you, and open it up. And if you're not familiar with that, we can show you guys how to do that. Essentially, just throw that data layer in the GIS, and then go to the attributes and export that as a table or as a CSV.
So the attribute table is where you'd probably find that data set then.
So this data is in a tabular form. It's just it's made to be easily sucked into a GIS. And so all we want to do is just take off some of that extra stuff. So it's already in that form. It's just it doesn't look like it. And so from the visualization, you can go in and look at what are known as all the attributes. So the county and the whatever home prices and all the different variables, and you can just go in and select, hey, I just want this data and take it out that way. So again, you don't have to do that, but if you guys do find these map-based data products, you can get that data out of there as well. Oh, that's all I'm saying. That's all I'm saying. Okay, great. Other feedback for these guys? Or other questions? All right, cool. All right, number next. Thanks, you guys. Sea level rise 2. All right, ready, steady, go for it.
So we also have sea level rise. And what we were thinking for our hypothesis is sea level rise posing a risk to the California coast by damaging the infrastructure and displacing communities due to the coastal erosion and flooding.
So this was the first data set that we looked at. This is not in tabular form, it's in map form. But this shows potential flooding of a 100-year storm at different levels of sea level rise. And this is in centimeters, so that shows like 50 centimeters of sea level rise of the 100-year storms covering, this is the San Francisco airport. It covers half the San Francisco airport. This is North San Diego Bay, and this is the Port of Los Angeles and Long Beach.
Mm-hmm.
So this is some of the other data that we were able to find. This chart up here shows the average level of sea level rise that we kept seeing in multiple papers. And this is just some of the data that is contributed kind of towards that graph.
Cool.
And then this was just a comparison of potential cost of sea level rise extreme storms plus extreme storms in California. With this showing that in the 2040s, an extreme storm with a sea level rise could cost $32 million, or $32 billion, sorry, this is in billions. And that in the 2100s, sea level rise plus extreme storms in California could do more damage than Hurricane Katrina, which I thought was quite a drastic number, $150 billion.
So I think the governor just asked for $40 billion as the first installment from the federal government. That's just the federal government's initial contribution for the two fires that for the Eaton and the Palisades fire. So it's going to go up a lot. And so the current talk is it's probably going to become the most expensive natural disaster in U.S. history. And so that's just one event, right? And even though we forecasted this, it is probably going to be blow doors on these. So yeah, cool.
Crazy.
Merry Christmas. All right. Cool. All right, great. Thanks, you guys. Oh, sorry. Feedback for these guys, or questions or comments for these guys.
Thank you.
So do you think you're gonna focus more on the cost of it, or actual metrics of sea level rise? Like, because you were asking about the GIS component, which won't really build in cost, but you'll get other types of actual height data or something.
Yeah, I thought the cost was an interesting thing to compare, and it was always a good metric for, understanding potential damage.
Totally.
So, yeah.
We're still exploring.
Yeah.
Cool.
Subject issue.
Cool.
Right.
All right, marine heat waves.
So our hypothesis is due to the changing climate, marine heat waves are becoming more frequent. Areas of high biodiversity such as coral reefs suffer from the detrimental effects of marine heat waves. And it creates a domino effect that affects other organisms.
Oh, it didn't update.
Oh, is it?
This slide.
Is it?
Well, I can explain it.
Okay. Okay.
So zetajoules is a measure of energy in the ocean. This is sourced by NASA. It was really hard finding data. I'm just gonna say that right now. If you know how to get a .nc to a CSV or an Excel sheet, please let me know. But this is basically the zetajoules energy of the ocean over time. It was 92 to 2020. But if we go to the next slide, you can see that there is an increase of zetajoules in the ocean. over
Also,
time.
zetajoules is like a really high number of measurement. It's like joules with 21 zeros
Yeah.
after it.
Imagine pi, but the decimal point is so far back.
Yeah, so it also seemed a little confusing that this was what they're using to measure the heat.
Ocean warming,
Yeah.
yeah.
But that's what we were able to find.
More research is needed. Like I said, if you know how to get a .nc.
Catch us next week.
So, yeah.
Yeah, the ocean is a massive thermal battery. I mean, there's an insane amount of energy stored in that water.
Yeah, so this is kind of like, oh, the ocean is warming, but with the heat waves out on top of it, it's going to be hotter. So that'd be interesting to see how, how many zetajoules maybe a marine heat wave gives. Questions, anyone?
Cool. Feedback for these guys?
What is the x-axis?
This was improvised. I could
The
tell you
zetajoules?
in a couple minutes, okay?
I think.
I could let you know.
Oh no, these are the years maybe? No, okay, never mind.
Something to myself.
Sorry, guys.
Leo, you have a question?
Oh, I was gonna ask, well, I was gonna say that with cleaning it up, you probably, I don't know why there's, well, I guess now, no, I see why there's.
Yeah, cleaning it up is something I didn't do, so
Okay.
I will get back to you all with the cleaned up version.
More to come, you guys.
I will
Y'all
work
are
on-
not quitters.
We got another checkpoint,
Some like data sets I found too, most of them were like maps, like GIS stuff.
Mhm.
It's like, okay, I couldn't find the actual Excel like spreadsheets of that, so it was hard to.
Yeah. So I would say, another thing, again, that for when you guys are hunting for stuff, also try looking for some other terms, because marine heat waves is what we're now calling them, but people have called them other things like the blob and other things of that nature. And I'd say that in the context that you guys are looking for, one thing is to look for like the central tendency of the change, right? So in this particular figure, maybe what's drawing our eyes is the orangeness and the sort of like the orangeness of the sort of going up of the orangeness. But and sometimes that's the important thing to look at. In other cases, it's the deviation from the condition. So in other cases, it might be the little blips, which might not look like a lot right now. This is an insane amount of energy. So even though it might just be a little teeny blip, that might be a huge change for the critters or stuff like that. I would just say sometimes you want to look for the main central tendency, sometimes the deviation from that. So that's cool. All right, did you want to say anything?
I mean, I think depending on if you want to look at like the entire ocean, right, or if you want to look at like a certain section of the ocean, that's where like Dr. is saying, like, the blob was a big deal for the marine scientists for a while, and it's centralized in a more confined space of the ocean. But even just looking at NOAA buoys, like you
Yeah.
kind of know, we all know when it's been hot over the last 10 years and when it hasn't been hot. That correlates with ocean temperatures. So you could even just look more on the local side and just say like
Ventura County or something, yeah.
Ventura County.
Yeah.
Because they have buoys that are in .csv files, use them all the time, right off of the coast. You could just have it right in like local, like in the harbor, or there's one in the Port of LA. There's all these, and they're collecting data like, I think a lot of times it's at least by the hour, but sometimes by the minute. And so it's like very rich data, and you can do a lot of cool things with that type of data.
That sounds
Cool.
Yeah.
Cool. All right, thanks you guys.
Yep.
Okay, our drought people. Where's my drought people? Okay, cool. Ready, steady, go for it, you guys.
Our topic is droughts, and our hypothesis is California will continue to face worsening drought conditions due to warming temperatures causing a narrowing wet season. Proper water management strategies will be needed in order to conserve freshwater resources.
Cool.
So this is the first data set we found. It's per kind of city in California. This was on that side of it. And then I try to show us binning, like making our own category. So we highlighted like the top 10 like most populated cities. And then this is the total sum by every 5 years.
Cool.
And then for the figure, it's not the best, sorry about that, but on the x-axis we did the cities in California. We just narrowed it down to the top 5. And then each color is a different year, and then the y-axis is how many gallons that were used. And it's not the best. We kind of wanted to switch the colors, like to put this on the X and these as the colors instead, but we couldn't figure it out.
Cool. Okay. Was there that? Okay, yeah, good. Okay, so feedback for these guys or thoughts.
I know you don't like that, but I kind of like that. That's being, I don't know.
You mean you were talking about the color?
Well, just like the way it's set up, like not over year, how you look at each one and then you're looking at their over year by each one. I don't know, it just looks less confusing like that.
Maybe that's why we couldn't figure it out.
Yeah, I like it too. Yeah, because I feel like you're able to identify which city you're looking at instead of trying to find this city in that. Like you can say in Anaheim, in LA, and you can instantly see how much LA is using more than the others.
I think also you could go into the type of water usage, so like agricultural work,
Yeah,
that kind of stuff.
I'd also say, so what year is this data from?
On the thing it said it finished in 2010, so the rest
Right.
is all predictions.
Right. So I think which is okay. I mean, it's what it is. But we actually know what we used in 2010 and 2015 and 2020. So you actually go and look and see how well we compared to it. But separate from that, it would also just be like if we were going from like a time. So I think like 2005, I think it already happened, right? Even in this data set, and the other ones are predictions. A great thing to do would be to somehow sort of reinforce that for the viewer. So maybe the predictions are maybe a hollow bar or a hash bar or just something so that people are just glancing and say, oh my gosh, okay, I get it. Yeah, the blues are all the same year, but there's what we measured and then what we think is going to happen. You know, the forecast and the actual saw. So that what we actually saw. So that would be a good thing to sort of carry over into the next time. But cool. Other thoughts or other feedback for these guys?
You have some good data with, you have some predicted data here, but for every single one of these cities and counties, you can go and actually see how much it rained that year. So like you're going by year, and so for every city, it's really easy to find this data where you can say this is how much rainfall we got for the year within that jurisdiction, city, county, whatever, or even like during the rainy months. So if you even wanted to like focus in on some kind of like where drought's the most impacted, you can get like a lot more detailed data on actual rainfall too. So there's the usage aspect, but it's also what you're getting in. So
Yep.
it's all really easy data to get. That's cool.
Cool. Good. Other feedback for these guys or other suggestions or observations? Okay, great. All right, thanks, you guys. Wildfire team. All right, ready? Hey, you guys ready? Ready, steady, go.
This was that climate change is causing wildfires in California to be larger and increasing frequency. So basically, there's a trend towards larger burning and more frequent fires in the years. And we think from the data we found that it's predominantly caused by drought, and the drought causes more brush to grow, dry plants, so fires catch faster and they burn a lot more, and temperature increases.
Cool.
We found two main data sets. The first one was just like the drought data for the areas. This was like the main website of it, so it has the like URL on the top. You can go and it will like explain what each thing means in the data set. You go to the next one. You can pick what dates you want for like your data set and what area you want it to be in, and then you click submit and it will create an Excel sheet with your data set. If you go to the next one, it'll show you one of the ones I made, just very like, and there's more in it, but it was just like picked what like time frame I wanted, and what area I wanted to do it from, and it will just give me all this data. And then from the first page, you could like see what each thing means. I just got like the DO is like based on how much it like they would consider the drought level. If it's a 0, it's like
not as bad of a drought, but D4 is like a really, really bad drought kind of thing. If you go to the next one, this is like just a basic figure of that data that was in the last one. I think we would change it more like, cause it divides it up by different months that they did the testing. So there's a lot, you can see where there's multiple 2024 kind of years, so you maybe like just combining that data into finding an average for that year instead of, multiple, so, yeah,
Cool.
you can go next to that.
Cool. All right, great. Feedback. Oh, sorry.
There's another data.
Oh, sorry. Oh, please. Oh, I'm sorry. Please, can we go?
Yeah, so we have another data set, and it's also on temperature. This is just the site that we got it from. And the next part is the data that we got. So we were looking at specifically like the span from 2000 to 2024. We could pick the range up there, and we got just the mean average temperatures. So on the next slide, we have two graphs, and they're really helpful. So the next slide as well also is another temperature graph, and it doesn't look too clear until you compile it into Excel, and it gives you a graph that is kind of simple, but the next slide is a simple but more concise graph of the difference between 2000 to 2024, and you can see the trend going up higher in temperatures.
Cool. All right. Great. Feedback for these guys.
I would say all of your graphs are amazing, but for this graph, the temperature, you could make it like the y-axis between like smaller points, so it just looks more drastic. You know, that might be like making a data bias or whatever, but I think it's like.
Sorry, you mean make it go from like 68 to 76 or something?
Yeah.
Mm-hmm. Yeah, that's not biased. I mean, that's not. I mean, as long as you're being, excuse me, as long as you're being fair. Excuse me. Sorry. If we did extreme, if we had it 0 to 300 degrees, right, it would look almost like a flat line. That might not be helpful. And if we were to make it, 68 to 70, right, it would be like a cliff, right? So obviously there's a trade-off. What the statisticians would tell you is that what you're supposed to have is the range, the biggest number and the smallest number should be represented in there. So if this is how it plotted out on that data set that was being visualized here, there was never a temperature less than 64 and never a temperature point greater than 78. That's what the statisticians would say, to be totally transparent with your data. But sometimes, just because ecological data is noisy, there might be one data point that's up there by 78, and so it's okay to sort of truncate the range a bit. But again, we're trying to make sure the patterns are easily seen and interpretable. So that should always be your guide. And so maybe you want to have it tighter, maybe a little bit wider. But yeah, it's a great one to do an iteration of. Well, what if I made it look like this? Is that more helpful? What if I made it look like that? Is that less helpful? But cool.
I think just thinking like looking at this one, if you put like a Y2 axis with frequency of wildfires, it would directly tie it in the same graph would be kind of cool. I'm not sure what it would look like with that temperature graph.
We'll have to tinker with it because we're talking about stuff separately, but we are gonna get graphs and put them together so that we can see the correlation.
Have you guys noticed a correlation already? Have you noticed somewhat of a correlation between temperature?
I want to say loosely yes, but just because our data is mostly right now drought and temperature, and then we're gonna cross it over with wildfire mass and frequency.
Maybe instead of mean temperature, maybe like highest temperature recorded that year could be something that might line up more with wildfire.
One thing I think is, it just kind of popped in my brain, but I think it overlaps with a lot of your subjects. It's just something to think about. Is like these patterns with El Niños and La Niñas, right? Which really changes. So we have ocean temperature, right? But that also changes a lot of the temperatures and types of climate impacts on the coast, and that's changed drastically. So I don't know, a lot of you might be too young for this, and I hate saying that because I would feel like
You're so old.
But El Niño and La Niñas have changed drastically in like the last 10 years, right? So like I grew up and it was like every 6 to 7 years you would
Yep.
get an El Nino. You could
Yep.
almost map it.
Yep.
Like it was crazy. It was up. It has been about 5-6 years. It's gonna be an El Nino season, and then an El Nino would hit. We've lost that. We've totally lost that. And so we had like 3 El Ninos in a row. And so, does anyone know the difference, the true difference between an El Nino and a La Nina?
Isn't it like which hemisphere it's in? Or no?
No, we get them both here. We get them both up. We're currently in a La Nina.
Direction,
Nope.
temperature,
Temperature of what?
the ocean, the wind.
We're just throwing stuff out there.
Bet it on the red, baby.
You said one of them.
The ocean. I'm sticking with
The
that.
temperature of the ocean. So a lot of times people would get confused because usually El Niños would bring more rain, right? So everyone would like really say, oh, it's El Nino, so it's cool and you know we're gonna get more rain. El Nino really means warmer sea surface temperatures. So it's ocean. The ocean warms up. That's that blob that we're talking about. So this is kind of why it's all like I think it overlaps with a lot of you, and there's data sets out there. As a fisherman, I follow El Niños like crazy because El Nino means that there's going to be
Red crab.
red crab and tuna on the backside of Catalina. Right? So for 3 years in a row, we had bluefin tuna on the backside of Catalina. But that was unheard of, so we've never had that before. So it also there's some of you that are talking more on like the animal side of the thing, right? And so La Niñas mean that it cools down, but we get drier here. And so when it comes to like wildfires too, during El Niños we get more rain, which we had the past couple of years, right? More rain means more growth of vegetation. So now a lot of our vegetation out here is like really, really, really abundant, or it's really, really thick. And then all of a sudden now you have a dry year. It might not mean that the temperatures are warm, like we're feeling it, but the ocean temperatures are warmer, it brings drier conditions, and so then we can also have these variations in winds and wildfires too. So it's a weird thing to just throw out there if someone's interested in it, but I feel like that is something cool that kind of is for everybody.
Yep.
And I think there's data sets out there, so that's why. So I think it could be a link for a lot of your projects of just linking that aspect in.
Cool.
Yeah.
All right. Thanks, you guys. Another one is I just noticed this real quick is and this has come up a couple times. Units. So generally, our default is to use scientific units. Okay. So sometimes your data sets will be in another metric, but we want to always strive to at least have the scientific units. So that would be Celsius here, right? So we want to use Celsius, and then if you also want to include Fahrenheit or hectares and acres, you can do that, but our default should always be to use the scientific units, not the imperial units. So just as a kilometers, not miles, and so on and so forth. Okay, cool. All right, number next, extreme weather people.
What about me?
All right, ready, steady, go.
Okay, cool. So we're kind of working with like dual hypothesis. We're gonna kind of see which one sticks out. We're extreme weather. We're kind of narrowing down onto extreme heat because we're trying to go into the California lens. We see lots of heat. We have the California Death Valley in particular. This is like old news, but like Death Valley has the highest like recorded temperature. It's like 130 degrees Fahrenheit. But our hypothesis is that extreme heat has become more frequent, and because of this, the ecology has to adapt and it has to figure out how to deal with extreme heat.
Yeah. So I thought the hypothesis was like perfect. This is exactly what I would want to research, but I wasn't sure there'd be a lot of data on the ecology in California adapting specifically, or because it'd be hard to like find. Or I mean, I was already struggling finding better data, so I wasn't sure how easy that would be. So I just kind of rewrote it a little bit and basically said the same thing, and then I just said instead of like the ecology in California, I said every aspect of life. So climate change has caused extreme heat to happen more frequently and more extreme than ever. This is changing almost every aspect of life in California, so I figured we could probably touch on ecology if we could find the data, and then maybe touch on like people and stuff like that.
So this is a fragment. As you can see, there's like 700,000 rows to this. I don't know how my computer even knocked down. But this is day-to-day weather. You're gonna find out why there's so many. It's like hour-based weather. And I found 39 different stations, but I just took it from the first one I saw, which was Yuba County, which is near Sacramento, and it's just temperature data that goes back to the 30s, and so
Cool.
we're hoping to find good stuff there, and we want the data to look like that.
Yeah, I wrote all this. I'll just read it directly. I don't really want to rethink. If you cannot already tell, the following graph shows the number of extreme heat events at night in specific areas along California. It ranges from 1950 to 2023, going from left to right. And as the colors get darker, the number of extreme heat events goes up. As you can see by the data visualization given, as the years go by, the average number of extreme heat events goes up. You can tell by the gradual change from light to dark. So like this is dark. This is over here, it's like light, so it goes from like light to dark. If we paired this visualization along with one stating the rate of climate change rising, we would be able to see both rising at the same time. Unfortunately, it would most likely not be like in the same format because this is all like colored, and I didn't really want to find a new data set and then make it into this, or like figure out how to make it into this, but that'd be like a cool comparison is what I thought. Yeah, that's it.
Cool.
Any questions?
Okay, cool. All right. Thoughts for these guys, or suggestions or observations?
So is it going from like year 1950 all the way to 2030?
1950 to 2023.
We did not make this graph.
Yeah, we didn't.
We just wanted to look
Oh.
like this.
Yeah.
Oh, I get what you mean. You want, this is what you like want to use as a reference.
Yeah,
Gotcha.
Cool. Another thought is, so one is to just plot the raw data, which is totally fine, right? There's nothing wrong with that. But another one to maybe help you guys with your hypothesis is maybe to have some kind of level or trigger condition. So maybe it's that after you get, I don't know what it is, 3 nights of above 100 degrees Fahrenheit, or that triggers bad health consequences or something of that nature. So one is to just sort of show this sort of nice pattern, and you can see the overall darkening of the red or the heating up of the illustration. The other would maybe to sort of, once you hit one of those things, maybe make it just solid red or green or something, right? And so you could sort of see like nothing over on the left, and then all of a sudden start to see many more of those bad times. So that's a threshold condition. Once we've passed that's another way to think about looking at the patterns.
Another thing, so a lot of your projects, I mean, these are all really great. I think you're probably finding out that when you keep it really broad, a lot of times, it's really hard. So like as an ecologist, it's gonna be hard for you to find ecology data sets, right? And so usually ecology is built in. You'll have maybe a vegetation data set over here. You might have a bird one over here, right? You have to compile it together. So you can think something kind of like what David said too, where you could do like, you can find 1 or 2 species. Maybe focus on the red-tailed hawk or something like that, but maybe there's something that really is influenced on temperature, and you can find a data set on an amphibian, right? Or some desert hole pupfish, whatever it is, and then you see what their thermal max is, maybe that's known in their ecology, and then you can go in and say how many days above a certain time, their threshold, did it hit that, right? Is it increasing over time, whatever? So, think about you get more detailed, but sometimes just focusing in on one species, there's one grad student out there that just share their data set right on one.
Yeah, right.
You might not be able to have this big, awesome like ecology thing, but you could do something really well if it's just, a specific species or one focal, part of the question or something like that.
Yeah, I mean, my PhD, I worked on I worked on a couple different, but really main one type of algae. Professor Spies worked on one species of fish. Dr. Horn and I published a paper on one microplastics in one organism, right? So I know we extrapolate these things, but it's really hard to study California. It's easier to study a component of California or a component of Ventura County or a component of the campus that's here. And it's just a lot easier to get our arms around a lot of times.
You can make inferences, right? So if that bird of prey, you know, if you find a really good data set on red-tailed hawks, and you can do that really well, that would infer that other birds of prey in that area are probably are being impacted similarly, right? Or if you have one on one plant in Death Valley, right? Death Valley is actually like pretty epic place to have like wildflower blooms when it rains, right? But if there's someone that did one or two plants and then like you're not seeing plants anymore, then you can infer from those data sets that it's going to impact all these other similar types of plants.
Yep.
So you can think about it in that term too.
Choose like an indicator species or something. Like
Sure,
that.
It's like
sure.
an indicator.
Foundational to. Okay.
Cool. All right, sweet. All right, good. Nice. Species distribution.
Alright, so hello, we are doing it on species distribution shifts, and so we will have full disclosure that we did not realize until we entered class that we were supposed to be specific on California. So we were talking about the climate change and the difference in sea surface temperature and how that is causing distribution shifts in whale populations. What we were studying was North Atlantic right whales, which is obviously not in California's coast. But if anything, now knowing that, we can definitely try to maybe hone in to maybe like humpback whales and gray whales and blue whales that are native to like the California coast. So next slide, please. So again, this is wintering habitat for the North Atlantic right whale. Again, we would then change that in future. That was just for the website, and then this is the data set that we were able to find, which I was really happy because it was a nice little clean data set, and it was just showing the year that it was documented, and then the observed sightings. And so me and Becca were both agreeing that it's a little odd in the wording that they used. Sightings is referring to a unique individual, while observed whales is how many times a whale was spotted in this area. So that means there was in 2003 and 2004, 137 whales were identified, and they were seen 259 times in totality. This shows you the area that they surveyed, and then the rate by which whales were being observed. Next slide.
Okay, so here is our first figure that we created with the years, and it's kind of broken up because the seasons that they tracked, it started at the end of one year and continued into the next. So it's by kind of sets of years, and then on the, what is that? Your left y-axis is the total number of observed whales and sightings, because those are on the same, what's the word I'm thinking of? Same ratio, I guess? Yeah, sure, line. And then the sighting rate, I realize it's not a percentage, so ignore the percentage, but that correlates to this gray sum of sighting rate line.
Okay.
And you can see they kind of follow a similar trend, and we still need to look more into that. But there's also a Pacific right whale species that we are trying to find data on, since we found this one in the Atlantic.
Cool.
Yep.
Very cool.
All right. Thanks, you guys. Good. Thoughts, feedbacks for these guys? Ideas, observations, comments?
I don't think you guys wasted your time. I think you could use this data as like a comparison to California.
As a comparison, I didn't even think about that. Well, yeah, that was why I was kind of thinking to myself, I'm like, because I went to Maui with Dr. A, and we were observing humpback whales there, and then when I was asking the former CUCI professor, she was saying like these whales go all the way to Alaska, and so their range is huge, and that's why me and Becca were both thinking like it'd be really interesting to look at the distribution shifts in these whales. Like, are they going to different locations?
And that's why I thought, like, well, North Atlantic is, you know, still part of the ocean. But yes, I actually wouldn't even consider that comparison. That would actually be a really good idea. Thank
Yeah,
you.
yeah. So just like Professor Spees was mentioning, you could, instead of looking at like all critters or all birds, you could look at, you know, a subset or whatever. Same thing with these guys. You could pick so a lot of times our observations are based on particular points, like Point Furman or different places where it's relatively easy to monitor the whales, or say like Monterey Bay or something like that. And so one, you could try to get like all the whales in this chunk of the ocean, and sometimes you can get that. But you can also, just like you could narrow down on the species, you could also narrow down on the geographic area. You can just say, hey, for whales going past this point, you know, how many were there, or what time of year do they start versus finish, or something like that. So you can both narrow down taxonomically, you can also narrow down geographically. We saw that with some of our you guys were doing the temperature thing, right? You could do California temperature, or you could just pick like Yolo County temperature or something, right? And that is not bad. It's not bad to sort of truncate your data. It's a way to get our arms around the picture. So that's not bad. And I do agree that this is not wasted. So we want you guys to have some kind of nexus in California, just because for most of us that's going to be easier to find data. But that was it. It doesn't mean you can't use data from elsewhere. We're not saying that. We just want to sort of give a touch point that we can, because we have more facility with the California data and stuff.
So would we focusing on something like the Santa Barbara Channel and like because I know that there's a lot of whales that go by, like maybe documentation of that?
Mm-hmm. Yeah, so in places like Channel Islands National Marine Sanctuary, Monterey Bay Aquarium National Marine, or Monterey Bay Aquarium, Monterey Bay National Marine Sanctuary, they have specific programs to monitor whales. Okay. And then there'll be also different friends of groups. So there's a group in Carpinteria. So you can go to those different, so we call these observatories or observation points. And so with birds, we call them observatories. So there'll be different, sometimes they're like a university, but sometimes it's just a nonprofit. And they do that. And also what you might find for the whales is also sometimes ecotourism groups. So like the boat operators will sometimes keep logs. And so they might know for Monterey Bay or the island packers, you know, how many times they see a gray whale or whatever. So there's a whole variety of large data sets, but also, you know, geographically narrow data sets that you guys might be able to get access to.
I think, yeah, like specifying what kind of observation, like if you reduce that, that would probably help you gather your data if you're like only whale sightings viewed from a boat, you know.
Yeah.
Or if you just pick one of those.
For species distributions, the common ones off California, there's really key features that it's usually more well documented for like fish and algae and stuff like that, but they tend to follow up the food chain. And so the barriers like further south are like where you really get limits are Baja, right? Central tip of Baja. Here it's Point Conception, so it's where California bends up. And so that's because there's a rocky headland there, but it's also a big change in current, right? The way that the currents hit that. So it changes the ecology of those systems. That's why right now you don't get sea otters below Point Conception really, unless it's out on the island. They're all right above Point Conception.
No redwood trees south of?
No redwood trees, all that stuff. The other ones are Monterey Bay. So Monterey, there's a huge rocky headland, lots of upwelling. So it completely changes the ecology of the system. So that can influence a lot of marine mammals, because if you have more algae, you'll have better plankton, you'll have more bait fish, you'll have all those things, right? So Monterey Bay is one. San Francisco Bay, that's just like a break, a big, huge break in California. And then usually up to like Alaska. And so those are keywords that you could use too, because a lot of those trends when it comes to species distributions are those kind of barriers for geological features.
Cool.
Cool, thank you.
All right. Keep it up, you guys. Good job. Okay, my snowpack peoples. Snowpack. So we only have one or two. We can take a quick break after this, but if you guys just hang tight so we can get through these last couple presentations. All right, cool. Snowpack people, ready, steady, go.
Good evening, everyone. Kim and I are working on the decline of snowpack. So relevant to California, this snowpack is measured even more than monthly at the Sierra Nevada mountains. So our hypothesis includes climate change driven by rising global temperatures is causing earlier and more rapid snow melt, leading to a reduction in snowpack duration and volume. And we're still trying to hone in on what we want to focus on. The snowpack is a great indicator for, it's like a little water bank that we have, a huge water bank that we have in California. So we could focus in on the San Joaquin Valley and agricultural needs and water supply that the snowpack provides, or even the state water project that leads to Metropolitan Water District that leads to our water supply here. So, I mean, and there's other things that we could focus on, but next slide, please. Through one of the California Natural Resources Conservation website, we were able to generate this data set. It's a small data set, just the past 2 years, but we can see, and there's different functions that you can add or take away from, but we wanted to see the snow water content and also the snow depth. I mean, yes, the snow depth is important, but how much water are we gonna get out of that snowpack once the hot summer months come in and the snow starts melting? So this is just one of the data sets, but there's tons and tons of information about the snowpack. Next data set.
So this is just a reference, we didn't make this, but we kind of just want to make like a time series of what we can get, like the water, or like the change of snow depth that we see changing within climate change. So we're thinking about using maybe the date of year and as well as the year, and for maybe 2 locations in California to see what the change in like San Joaquin or in the other location you said, to see if there's a difference and how much we can get as well.
Cool. All right. Feedback for these guys? Any observations or suggestions, you guys? Any observations? So I'd say one thing you guys definitely, so all the modeling shows that there's definitely something going on in sort of eastern and southern Nevada, Sierra Nevadas versus the sort of more northern. So I think it does make sense that you guys pick at least 2 different sites just because it might tell you a different story.
There's a lot.
Yeah.
I like that you guys explained what like a snowpack was. I feel like that was like really helpful context before you like went into it.
Oh yeah, the snowpack is the snowpack season is during the winter months when we get the rainfall. The Sierra Nevadas get the rainfall, so the snow is measured monthly, but there's a yearly report that's put out in a lot of the state websites, and it changes because there's many. You know, there's like the California Water Department, and then there's they have sites as well, but essentially that becomes a deposit of water, and that snowpack, once it melts, it goes into the San Joaquin Valley. A lot of the farmers in that region will use that water, and a lot of that water will go into the State Water Project. That State Water Project is hundreds of years old. It's don't even want to get into that contract, but it essentially is part of the reason that we get water here today. Not too much information.
I'll just add that it's about 100 years old, not hundreds, but 100 years old. But also, just, you guys probably know this, but so there's a depth. A lot of times we talk about the depth of the snowpack, which is important, but also there's the amount of water content. So sometimes the snow is very flocculent, like if you guys have ever gone skiing, it's very kind of like powdery, and other times it's more like a slushy, more like almost like pure water. And so they will measure both of those things. They'll both measure depth and they'll measure the concentration of water. So when you guys are looking, just make sure you're keeping track of those, because sometimes those variables can be a little confusing. So you know what the unit is that you're representing with the snow. Cool. All right. And I think our last one, is our last one? Okay, cool. All right.
So our topic is about mental health and the effect of climate change on mental health. And I feel like this topic is kind of difficult to find data for because it's more qualitative and it's like very broad and there's a lot of impact on mental health, so it's kind of hard to find like a correlation specifically with climate change. But our hypothesis right now is that climate change disproportionately affects the mental well-being of California residents in comparison to other places.
this was some of the data that we found. It's a little different because obviously you can't just, you know, get a thermometer and measure how anxious people are feeling. This was a survey, and they were asked to answer some question related to climate and sort from 1 to 5 how like anxious or nervous they felt about the climate. So yeah.
Cool.
And so what we did is that we took a bunch of the data and we sort of averaged out which questions, which responses got the most, which responses were responding to the most, like which ones appeared the most, with sometimes, often, always being a lot more common than rarely and never. So one problem that we ran into, as Autumn was saying, is that we had a really hard time finding data for this. So I believe this survey was for Canada, not California. So the current plan is just to use it as like our measuring stick to to compare, you know, to California. But yeah, we were having a hard time trying to find data. We might have to narrow down our topic and change things a little bit.
Yeah.
Cool.
We happily accept suggestions. Please.
All right, cool. All right, thoughts for these guys?
Oh, I'm sorry.
No.
Go.
I was gonna say, if you need like, something to kind of like compare it to, you could use like the rate of like climate change per year, and then you could do like the rate of like, I don't know, how many people on average feel like, I don't know, like seasonal depression or something like that.
I was thinking something along those lines as well. My thought is that because there's so many evolving factors in the world besides climate change that impact mental health, like politics is a big one, or like just like generally the state of the social world. It's like there's a lot of like other things that impact like mental health. So like we could do that. My concern for those, like, you can say like, oh, there was an increase in average temperature this year, and there's also an increase in anxiety levels, but it's like, that's not really a correlation. You can't say that. Like, I can make the graph, but I don't feel like it's really saying.
Yeah, so correlation is not bad, right? So we would like to have a causal relationship, but still, to start off with maybe your first figure, your opening thing, totally not a problem to have a correlative relationship. That's okay. That's okay. Somebody else had a, yeah.
Oh yeah, I was gonna say, this is a graph that you guys made, right?
Yeah.
Because I know that some people were saying that they were using the graphs. I was gonna say for this graph, you might want to make the colors, the deepening in hue or in value, correlate to their response, because I guess it's confusing that sometimes being the darkest color, always being a gray tone, and then never being the more white tone.
Yeah.
Like, I think it'd be easier for the eye to visualize it with always being the darkest color, and then often, and sometimes, and rarely.
Yeah. Makes sense.
I don't know if this goes with like what the research project like we should do, but we could collect your own data.
Yeah, we were talking about that as well, but I don't know. To me personally, I don't feel like it's like we have enough of a time frame to do that.
Ask us.
That's true. That is a good point.
Yeah, so I love the idea of getting your own data. I think that's a bit beyond the scope of what we have time for, but it's a great idea. Maybe a capstone project for next year. But it's probably a little bit tight to I won't say that. It's too tight to do that. So good idea, love the thought, but let's not do our original data collection.
I was thinking like as a way to quantify mental health apps downloaded per year.
Oh, interesting. Well, that's a good one. That's actually good.
Could
Might be hard to get for
something that could
California
show-
specifically though.
Right, yeah, it would be downloaded in California, which I don't know how you would.
So I would say one that you definitely can do, and that our friends in the psychology department do all the time. If you look at how many papers were published about universities, one of the critiques about modern psychology is everything is about 19 to 22-year-olds in North America, because all these professors always pimp out their students to do the work for them, right? They're like, hey, you guys, take the survey. And so in some cases that's considered a bad thing because it's not as generalizable to the whole population. But it also means that a lot of these types of things, do you feel anxious about when you read the headline about this? Does that make you worried or whatever? So there's actually a fair amount of that but it'll be in the psychology literature, and so it might not be some of the places we typically look in our databases, but they definitely do exist.
Yeah, I was looking in like the APA, which is
Mm-hmm. Yep.
Yeah. So they definitely did have like some articles about like the relationship between climate change and mental health, but I feel like a lot of it was very general. It wasn't like specific to a location, and like a lot of it also didn't really have data. It was kind of just like, oh, people feel sad when they lose their house in a fire, or people feel sad when they lose a job because of climate change, like stuff like that.
I think there's some stuff you should look into, just the availability or access to green space.
Mm-hmm.
So that's a common thing that's pulled now, and that's how, things like the LA River Revitalization Plan and things are coming around is to increase green space for people, because there are mental health benefits for people's access to green space. And so, you'd have to see what the data looks like. So you might have to find that Rosetta Stone to link it to something climate change related, or just make an inference where, these green spaces are now being impacted by various climate change things. But I think there might be data, that's one type of mental health data set that I think might be around, because I think that's, people are commonly polled on that.
Yeah,
especially
I think
in like LA counties and stuff.
But I wonder, like, would that, like, we can talk about it more actually.
Yeah, we should.
Cool.
Yeah, but cool.
All right, good job, you guys. Good job, you guys. Okay, so I think I was gonna say something, but I think maybe Professor Spees wants to go over your thing, or do you want to wait till Thursday? Okay, so I just want to say a couple quick things. One is, have fun. This is awesome. So we heard something about aspatial stuff. We heard stuff about the East Coast. We heard about temperature data. We heard about plants. We heard about birds. All kinds of cool stuff, right? I get that it seems frustrating when you're first starting off, but you guys are on a hunt. You guys are on an investigation. That's cool. That's super cool. Everybody is making progress, right? Everybody's making progress. So we're here to help you guys if you get stuck, right? We have these different levels because we don't want to just give you an assignment and have you turn something in 2 weeks, right? Each of these different levels is to try to help you guys along, and for us to check in with you all and make sure that we're getting a little stuck and not massively stuck, so we can help get you guys off that rock when you're not sure which way to go. But keep charging. Keep charging. The other one to say is, and I totally get it. We all feel like we don't know what we're doing. We feel like we're lost, and so this is not a good graph. No. Everybody look at me. No. Do not say that. Do not stand up here and go, this sucks, this is the thing, I'm sorry, I didn't have it. No, we're all learning. This is just a draft. It's all good. It's a stab. You don't need to apologize. Don't start that way. Just start off, here's my thing. Next time I want to do blah, blah, blah. That's totally cool to say. Do not apologize. Everybody look at me. Do not apologize. You're all learning. You're all getting stronger. You're all getting better. We don't want to overly state that this is the best paper ever on climate change, right? We're not doing that. We're not being arrogant, but don't cut yourself down. Don't take your knees off from underneath you. We're all getting better. We told you this is just an update. This is just let us hear where you are. So as we go forward with these and other things, don't feel like you need to apologize, because you do not need to apologize. Okay? So we're all learning, we're all growing, we're all getting better. That's what this whole thing is about. Okay, so I want to make sure that we're not starting off in a negative space. And that goes for capstone, that goes for any of your things, right? Not arrogant, but we're also not saying that we're lame, okay? So don't get in that mindset, because it's very easy to start to do that, and you start to self-feed on that, and then all that kind of jazz. Okay, cool. All right, great. So making progress, all that kind of good stuff.